to welcome everybody to the May Blockchain at UBC monthly research talk. Thank you for being here with us today. I'd just like to begin with land acknowledgement to note that I am coming to you from UBC Vancouver campus, and UBC Vancouver campus is located on the traditional, ancestral, and unceded territory of the Musqueam people. And the land that we're situated on has always been a place of learning for the Musqueam, who for millennia have passed on their culture, history, and traditions from one generation to the next on this site. So we're very pleased and privileged to be coming to you today from this territory. I have a very brief introduction to our speaker today. So we're going to have a presentation from the SafeCoin team, who are going to tell you all about SafeCoin. But in particular, Jeff Galloway is going to be doing the presenting. So Jeff's been doing blockchain development since 2013. So he's been in the space for quite a time. And he comes from project management and an IT focused background. He founded SafeCoin in 2018 and continues to strive to grow and improve the SafeCoin ecosystem and its core values of safety, security, and privacy. So we're really, and Jeff is based in Canada. You can give more details about your jurisdiction, your place, if you wish, Jeff. But it's, this is really homegrown in a way. And so we're really, really excited to have Jeff with us today to share with you about SafeCoin. So Jeff, over to you.
Thanks very much, Victoria. I really appreciate you having me. It means a lot. And also thank you, Sean, for everything you've done to set this up. It's been amazing. Yes, I'm quite excited to go over SafeCoin with everyone. And hopefully we can all share and learn from this with regards to generally where distributed ledgers are headed, or at least where we think they are, and help each other. So I'll start off here. I'm just going to move from my own face over to our slides, and we'll get going. Now, if you guys do have questions at any point, I'm not quite sure how the Zoom meeting is set up, but by all means, go ahead and ask.
Yeah, they can just put their questions in the chat, and you can pause to answer if you want during your presentation, or we can hold them till the end, whatever's your preference, Jeff.
Sure, yeah, I'm fine anytime, really. Yeah, so I can answer them as they come. Okay, we'll start off with our slide here and move through SafeCoin, improvements to Solana, and the accessibility of blockchain technology. We don't want to limit ourselves necessarily to just an improvement on Solana, but we have adopted Solana's technology and improved on it, and we'll talk about that through this and why we did that. So we'll have a brief introduction, and then yes, we will talk about Solana. That is the base technology we're currently using. It's not the only technology we've used. Solutions and improvements we've made, and then ongoing developments. We're constantly trying to improve, trying to have the best technology possible. So there's always new developments coming out, and the vast majority of it is volunteer based. People just really want to see great things, and so we get a lot of help that way. So SafeCoin is lightning fast and efficient proof of stake blockchain network built on the Solana code base. We are arguably the fastest blockchain out there using Solana technology. And we'll discuss a little bit about why that is and why that's important too. And also, I think more importantly, how it's achieved. Now, there are other competitors who also claim to be faster. We'll talk a little bit about why we chose Solana. There's some important reasons why we did, and why we think it's the best direction, even though Solana has had some issues, which we'll also talk about. Very, very important is that we are a community-based project. And we are focused on a number of things that not all blockchains are. We are very focused on energy efficiency. We want to see blockchain be more efficient in terms of energy use, in terms of resource use. And that's for a few reasons. One is for the environment, for sure, but also it promotes better communities when there's not high resource usage. And we'll get into why that is. Some of the improvements we made, which were key, were consensus and compression improvements. So we'll talk a little bit about those, especially the consensus improvements, which are always a really important topic in crypto. So our ecosystem's constantly expanding. So SafeCoin itself is a decentralized project. There is no owner, there is no specific governing control. Through SafeCoin, we've developed many different projects, some of which have sort of taken life of their own, become their own thing. In the very early days, one of the very first things we did was make SafeTrade. So SafeTrade is a growing exchange. It is centralized because when we made it back in 2018, that was the predominant way to make exchanges. We are now looking at producing decentralized exchanges. But SafeTrade itself has continued to grow over time and will continue to. We also have SafeChat and SafePay, which are, for instance, we can do a video conference on SafeChat very similar to this on Zoom. And our vision with SafeChat is to make it as distributed as possible and utilize the SafeCoin blockchain. And SafePay is one of our wallets we've made. Okay, so now we get into the meat of it. And by the way, people, feel free to jump in at any point if you've got questions. By all means, I'm totally fine. I'm totally fine with that. And somebody stop me if I don't see a question. I don't use Zoom a lot, although I have definitely used it. Solana has a unique multi-threaded architecture, which involves proof of history protocol and the ability, as they claim, to process 65,000 transactions per second. Now, the whole issue of how many transactions per second a blockchain can produce was always kind of not the best measure. It's just a convenient measure for purposes such as Twitter. It's not the best measure of the capacity or speed of the blockchain. And I think that's becoming more people are becoming aware of that, and we can discuss that further. I still feel that Solana is probably the most capable for a number of reasons, not just because of that 65,000 TPS number. Solana is able to handle extremely complex smart contracts better than any other blockchain. So this is something which it might be a little contested right now because Solana is having congestion issues, but I think it's still relatively agreed that Solana is the best for handling extremely complex smart contracts, simply because no other blockchains being battle tested the way they are. So we're seeing issues right now where Solana starts to have problems when they get around 4 million smart contracts processed per second, then they have issues. But I mean, if you were to compare that with something like Ethereum, Ethereum would probably start to shut down somewhere around 20 smart contracts a second would kill Ethereum. So Solana has had some issues recently, and the issues it's had is because it really has no controls over how many computations it handles at once. And so it's gone way beyond what any blockchain has ever experienced because of that. Now, we know it can do high throughput. It also has very, very low fees. So we're calling them gas fees here. They're called compute units for Solana, but Basically, everything has a fee in life. And so there is a fee for processing these smart contracts in Solana, but it's extremely low, lower than pretty much all its competitors. Okay, so a big part of this presentation is proof of history. And we can talk a little bit about why that is. Now, if you guys have questions about it, for sure, let me know. A big problem.
There's one question in the chat if you want to answer that now or later.
Yeah, go for it.
I can read it to you. It's just, how do you compare Solana with Polygon in terms of speed and fee? That was from Brian.
So it's very difficult to answer just with those two variables. So the other variable you need is the amount of computation or the amount of data, because we need to know in terms of speed what it's processing. So definitely different chains make different claims as to how fast they can go. Polygon was on the list of blockchains that we looked at when we moved to Solana. Their fees are good. Their fees are not bad. Polygon would never be able to handle the level of computation that Solana can handle. There's a few reasons for that. One is because Solana is multi-threaded, so it processes transactions in parallel. So it can have many transactions being processed by many threads at the same time. At least that's the vision. And in order to have, I personally, now I don't want to knock Polygon either. I know Polygon's very popular, but I do have to point out that if we had this meeting 2 weeks ago, people would be asking me to compare Solana to Luna. There were reasons why Solana had serious advantages, and the multi-threading is big. The thing about the multi-threading is it's really hard to add after. Like, in order to handle multi-threaded transactions, you pretty much have to build it in while you're constructing. Like, when you write the code for the blockchain, it has to be considered right at the beginning. It's very, very hard to add multi-threading in after the fact. Like, we're probably never going to see it with Bitcoin. So I do believe personally that without multi-threading in the future, there will come a point in the future where nobody will take single-threaded blockchains seriously, because they will just have that limitation. So with that in mind, definitely Polygon is a great project. Like, Polygon's a great project. We are trying to learn stuff from them as well. And they do have some great performance with simpler transactions. As long as the transactions don't get too complicated, as long as they don't get overwhelmed, Polygon's definitely one of the top DeFi projects out there. So I hope I've kind of answered that question. I don't want to totally knock great projects, because Polygon is a great project. I still think if you look at it holistically, Solana has the advantage just because it can handle many, many things at once, where all the other blockchains, including Polygon, can only do one thing at a time. We will also jump kind of back to that question later in this presentation. So we'll come up again, and feel free to ask more questions on it. So proof of history, this is big. This is quite big. Why is it big? So there's probably some people in this room who are highly advanced with consensus. So, hopefully I don't say the wrong thing. But when we think of consensus, we think of at the end of the day, we think of what happened first. When we're dealing with distributed ledger consensus, that's the key question. That's really what it comes down to. So in a centralized system, you've basically got the ability to handle X amount of transactions. It handles one at a time. Each one gets timestamped. It says, okay, I'm assigning this timestamp to you. You happen here. We're going to process you now. Then there's the next one. That one gets a timestamp. Everything's great. In a decentralized system, nodes are not. It's not that clear. It's in terms of saying, was the transaction set up correctly? Can we validate this transaction as a potentially valid transaction? With broad strokes, with very broad strokes, that's been figured out. You know, if you have a well-constructed decentralized system, transaction validations figured out. For the most part, very broad strokes. When the transaction occurred is not figured out, and that's where the problems start. So say you have an attacker who wants to do the traditional double spend. The attacker is essentially going to say, hey, I gave Bob these 10 coins at 12 o'clock. So 12 o'clock rolls around, and that's that. 12:30 rolls around, the attacker said, oh, actually, I gave these coins to Mary at 11 o'clock. So I forgot to tell you guys that. So actually Mary has the coins. And so that's basically your attack. It's very, very hard to solve. So the two predominant methods of solving this, there's dozens of different consensus mechanisms out there. But the two predominant are proof of work and proof of stake. So basically, it is somewhat of an unsolved problem. It's an unsolved problem in that there is no clear way to know which transaction did happen first in a decentralized system. So proof of work basically says, well, every block, we're going to pick one node who's going to make that decision for everybody. And who that node is depends on who's got the most hash power. And then that node's going to just determine which transaction happened first, which is great unless somebody manipulates through hash power and changes who that node is. So there's an attack vector there. Proof of stake, and sorry, this is very, very broad terms. Proof of stake is basically who's got the most coins. Whoever's got the most coins gets to decide which transaction happened first. Neither system's fantastic. They're both good starts, but 5-10 years from now, I don't think either proof of work or proof of stake is going to be looked on very favorably. Because who's got the most coins, that's basically how our banking system works. So they both have big issues. So there's a question, is there going to be an issue with time clock of the blockchain system with decentralization of time needed in order for time to sync proof of history? Yeah, I think there is still, and I'm not going to, it works. Is it perfect? No. This is the first implementation of, sorry, I'll move forward here a little faster. This is the first implementation of proof of history anywhere in blockchain. And so does it have issues? Oh yeah, yes it does. But so do all the other consensus mechanisms. So I'll try to answer that question a little bit better here. Okay, so I've kind of covered most of this slide. Proof of history is one of the first consensus mechanisms which is not competitive. So what do we mean by that is proof of work is essentially who's got the most hash power. Proof of stake is who's got the most coins. There's other consensus mechanisms, which is who's got the most disk space, who's got the most RAM, who's got the most free free processing power. There's who's got the most, yeah, it goes on like that. Basically, all of these are basically who's wasting the most resources, who can waste the most resources. And so none of them are very efficient. And because of that, they all have attack vectors. So this is the first one where they're basically saying, we're actually just going to focus on finding a way for each node to prove what time it is. So I'll move on here. And I don't mean to, I'll speed up on these other slides, but the proof of history part is important. So proof of history is a high frequency verifiable delay function that takes certain numbers of steps to evaluate which value, which provides a unique, we're going to move my Zoom stuff, a unique result that can be publicly confirmed. Said another way, and specifically what proof of history does is, in this case, it's a successive hashing of SHA-256 hashes. So it hashes a 256 SH hash, then it hashes that with another hash, hashes that with another hash in succession. That particular method is desirable for two reasons. The first reason is it only works on a single thread. You cannot do it multi-threaded. Single thread makes it a much fairer playing field for everybody. So that's just a cryptographic limitation of that particular hash sequence, is the single threaded is key. The other reason is because SHA-256 for monetary reasons, we've reached nearly the most efficient point we possibly can in terms of processing those hashes. So because there's a monetary gain in it, it's a very level playing field in terms of everything's very optimized for it. And so that way, when we see the hashes, we can make a determination of how much time it took to do them and assign timestamps to them. Is it perfect? No, but it does work really well. So the issues outlined in proof of work and proof of stake are overcome by establishing a cryptographically safe source of time for the network. So basically, if all of the nodes can prove what time they did things at, you've kind of solved decentralized consensus. Broad strokes. This really, really gets at the heart of the issue. And if you can solve it at this point, you've really opened the floodgates for what decentralized systems can do. So is it perfect? No, it's not. And that was a question asked. So, but that doesn't mean it's a bad way to go. It means it's the first version. So they chose SHA-256 not because SHA-256 is the best algorithm for this. They chose it, excuse me, because this particular method, excuse me, allows for an optimized experience. But there are other algorithms which are even more fairer playing fields, CPU specific algorithms, algorithms that are harder to game, that don't work with ASICs, that don't work with FPGAs. So there's the potential to make this an even fairer playing field than what it is now. This is really just a starting point. So the question is the calculation of time computed as the distance from the first block hash or in relation to a time clock? So it is the distance. Yeah, it's the distance between the hashes that they're able to determine a timestamp very consistently. So again, yeah, they didn't actually choose the best hash to do this. They chose the hash with the least amount of risk because we know so much about SHA-256. but there's other algorithms out there where you could get an even finer grained detail of time. So I think there's an opportunity for this to go much further than it is. Okay, so issues with Solana. So network congestion and halting issues began last November due to the large influx of network activity. So this is the cost of success. Solana became, as a lot of you guys probably know, if anybody doesn't, Solana became incredibly successful in the last crypto run-up. Solana gained more adoption than any other blockchain. They just exploded with adoption. Nobody else really came close in terms of how much adoption they got. It was by many magnitudes. And it's because the amount of processing that they could do of smart contracts, of dApps, is almost unlimited. At least it felt unlimited until around November of 2021. And that's when they started seeing the first limits. And I keep in mind, there's no other blockchain which has ever processed as much before. So Solana, of course, at some point was going to see a problem because nobody's gone this far before. So what ended up happening is they had troubles with, they were processing so much data. And that's, I'm not just saying the reason I'm saying data and not transactions is it's actual computations, which people were requesting smart contracts be computed. And those computes are actually what caused it to stop producing blocks. It was just too much to handle, simply. So why does this happen? One, so we have to be very careful here because I'm very confident that people in Solana will watch this video at some point. And we love Solana. So we really do love Solana. That's why we based all of our technology on them. And so hopefully I illustrated that in when I spoke about proof of history. So for lack of better words, we'll call this resource of intensive consensus. This is one of the issues. So we just went over, I just probably sunk in 10, 12 minutes, maybe more, talking about my love for proof of history and why I think it is the future. So Solana made proof of history. Incredibly impressive. They have a whole proof of history white paper. So then they did some funding rounds with venture capitalists. They got their marketing team, and then they said, okay, we've got proof of history. Let's use proof of stake as our main consensus mechanism. So after everything they developed with proof of history, they went largely with proof of stake in their consensus. And why did they do this? Is it because proof of history doesn't work? No. Is proof of history new? Yes, it's new. It's new. But again, like I'm speculating a little bit here, but when they went with a proof of stake system by and large, potentially because proof of stake systems are kind of their own economy. So you very quickly develop your own economy, where you have a bunch of validators making money, generating rewards. It creates entire industries. And crypto is very familiar with how that economy works and how you can profit from it. So that happened, and in addition to that, they had very high thresholds. What they required is that at least 2/3, if not more, of the Solana stake had to agree with the consensus. So basically, that's a very extreme proof of stake system there to be above 2/3 threshold. The reason they gave was Byzantine fault tolerance, and depending on how you interpret that, there's some validity to that. It's not the only way to do it. But what it does, so because Solana is an ICO, they own 50% of Solana. So it does raise the question, is if you only allow block progression when more than half of the validators agree on each block, and you own half of the coins, it raises the question as to whether you're actually a cryptocurrency or not. And I'm not saying they're not a cryptocurrency, but it's not very decentralized to have that requirement. And it's also it's an attack vector too, as we've found out, because if a very, very minimum number of validators struggle, the whole blockchain stops. So I think I didn't read the slide in front of me, but I've pretty much said the same thing. Yeah, I think the slide pretty much reiterates what I said. I just said it in different words. So I'll move on to the next one here. Low transaction fees with no design to account for more complex smart contracts. So this is another really, really big factor. Low transaction fees are fantastic. Everybody loves low transaction fees. It got brought up in an earlier question with Polygon, the fee comparison. Here's the thing with the fees though. Low fees are great until the low fees are actually lower than what it costs to produce the transaction or to process the smart contract. Once you leave reality and the fees are lower than that cost, you've opened up an attack vector. And Solana, without any question, did open up an attack vector by having fees so low that transactions were almost free. And so once that happened, it created a chain of events, because people learned that you could actually profit from producing enormous amounts of transactions for almost free. And as soon as there was a way to profit from it, Solana got slammed with enormous amounts of transaction requests, and people made a lot of money off of it, even though Solana could barely handle them all. And that brings us to that profiting. So the bots. So this is essentially, how do you describe this? You know how when a new Garth Brooks concert, that's how old I am. When a concert comes out, that everybody wants to go to the concert, and then everybody goes online at a specific time and waits to register to get a seat at that concert, and then the whole system shuts down because too many people try it at the same time. And then somehow the next day we find out the only people who got tickets are scalpers. That's kind of what the bots are. So basically, Solana became a leader in NFTs. And then NFTs, so there's an issue around, okay, well, how do you distribute NFTs, et cetera, et cetera. It led to airdrops. So long story short, there were huge numbers of airdrops happening on Solana. Some of them had fairly complex transactions. And some of these people started building bots, and basically you could request on chain, I would like an NFT, and I'd like that airdropped to me. So you put the request in. Somebody found out, well, I'm going to put in 4 million requests per second to get these, and then they got more, and so they made a lot of money. But the problem is, it got to a point where Solana just couldn't handle them all, and Solana would stop functioning properly. So again, this goes back to the fees being lower than the actual cost of producing. It created a situation where people profited from basically attacking, DDoSing the chain with an enormous amount of transactions. And it wasn't malicious, it was for profit. They're doing it to make money. So again, like this is all, it's not that Solana's bad, it's that Solana's had more success than any other chain with adoption so far. And because of that, it's encountering issues nobody else in crypto has ever encountered before, or very rarely. Excuse me. So, we right from our design, we did a few different things. One is we focused on efficiency. So we looked at the proof of history and we said, yes, you know what, we're going to rely on a proof of history a little bit more than Solana does. We think proof of history is potentially a future changing thing. We understand the proof of history is in its infancy. We totally understand that. But we rely on a little bit more, and we rely on proof of stake a little bit less. We still do proof of stake. We still do it, but we do it through random sampling, which means that we don't require everybody to agree every 400 milliseconds. Because when you do that, you're actually creating an attack vector for your chain. Because if you take out just a few validators, you can shut the chain down. So that's not a good idea. Yeah, so we do random sample proof of stake. We also found improvements in compression as well. And it works because of a few things, and one is the proof of history allows it to work. And proof of history is something in our roadmap that we want to continue to develop and hopefully become leaders in, and find better solutions so that we can rely more and more on that technology. And so far it's gone really well. So running over the improvements really quickly, we have, and people, yeah, feel free to butt if you have questions. Improved consensus is where we have, we use like 10% of what Solana is using right now, and it can be lower than that in terms of consensus resources. So Solana does something like 2,000 transactions per second, but 90% of those transactions are actually just for it to maintain consensus. Does it make Solana more secure? No, because if you take out a small number of those validators, you can shut the chain down. So why they're doing it, they will say it's because of Byzantine fault tolerance rules. There's people making a lot of money off of it too, though. So there's that. Optimized compression. We did find some ways in the code to improve compression. Now these are sort of things like, I don't know if Solana could compress as much as we do, because we're more efficient with consensus. It also allows us to compress in other ways. So these effects sort of benefit each other, and it allows us to multiply our efficiency on top of ourselves. And it ends up with, we have a calculated, now for what it's worth, and this is where we would love to have a study, but we've calculated that our energy efficiency is around 0.000027 kilowatt hours per second, or per transaction, my apologies. Now Solana is highly efficient. Despite everything I've said, despite all my slander, Solana is an incredibly efficient blockchain. And it's because of the multi-threading, because of many, many different things. And they're going to get more efficient than they already are, because they've only just scratched the surface with their multi-threading technology. All that said, though, because of what we've done, we are roughly 188 times more efficient than that. And so there's just a quick comparison chart. So basically, for various reasons, to run a Solana validator, you need to spend enormous sums of money. People say, rightly or wrongly, people say you need to spend $1 million to run a Solana validator. Is that true? I mean, it depends who you talk to, but you have to have definitely a massive computer system. an incredibly fast network. And you do also have to own a lot of coins or have somebody stake a lot of coins with you. We don't need any of that. And it's because the efficiencies that we discussed earlier with the random sampled proof of stake, with the compression, etc., allow us, it brings us down to, less than 10% of basically of the requirements that they have, computing requirements. And then on top of that, you don't have to spend enormous amounts of money to run a validator. And your validator still gets to participate through random sampling, and we still get all of that consensus out of it. So what that leads to is further decentralization. By reducing validator expenses, more people can run a validator to support the network. So basically, we make it accessible. Anybody can run a validator. If you really want to run a validator, you can run one. And you don't have to be a millionaire to do it. You don't have to run a data center to do it. We have lots of people running validators from home. Nobody runs a Solana validator from home that we know of. So it allows for far more decentralization that way. And it's working out very well. In addition, our proof of stake, we rely on less on our proof of stake, but our proof of stake is better distributed. So once again, as Solana being an ICO, of course, they own more than 50% of their coins. We don't own anywhere near that. And one of the great things about proof of work, I bashed proof of work a little earlier, but one of the great things about proof of work, and especially with Bitcoin, is you get a much better distribution of coins. And so we benefit from that. And so we've been fortunate, we were able to distribute our coins through proof of work, and which allows us to have a much better proof of stake system. So a product that just came out, actually just last week, is Safebridge. We've been working on this for a while. We're very proud of it. Safebridge is a completely non-custodial and decentralized means of blockchain interoperability. So in the initial stages, we can merge this with many different blockchains. In the initial, we've talked about a few. We've talked about merging with Varus and numerous others, Avalanche. But right now we do Solana and Ethereum. Ethereum being the first DeFi coin really, and then Solana being potentially the most successful to date. Basically, we're merged with them through this bridge, and users can move their coins and their tokens across the bridges, and soon their NFTs as well, in a non-custodial manner, where basically they hold their keys through the entire process. And we probably don't have time to actually run the bridge. I don't know. What do you think, Sean? Should we run the bridge? We're not going to have time. It'll take probably too much time.
Yeah, probably not enough time. I guess you could just quickly open the link if you want to show that.
Sure. I ran it a few times yesterday, actually, because there's another project we're working with that wants to use the bridge. And so we were working with them on that. So basically, here's the cross-chain interaction website. And you go to—
We're still on your presentation slides there, Jeff.
Sorry about that. How are we now?
Still on the slides. Oh, there we go. We got it.
Okay, great. So basically, the way these bridges work, everything's non-custodial, everything's voted on, and there's cryptographic proofs as well. The voters to determine the validity of these transactions are, in this case, are called guardians. You have a source chain, a target chain, you send your tokens, and then they get redeemed on the other side. So there's the 4 steps. You pick your source chain, such as Ethereum. You pick your target chain, such as SafeCoin. You move your Ethereum tokens over to SafeCoin. That's the send tokens step, and then you actually receive those tokens on the redeem step. And then, of course, there is also an NFT version of this and a separate redeem tool. So that's basically how that works. Now, these are an attack vector for sure. Oh, I've got a question in here, so I'll answer that question. I was just going to say these bridges are an attack vector. And that's something that we are working on. We're trying to make a truly, truly secure, safe bridge. And we probably won't have time to talk about it in detail, but we have some documentation on it. And this is something, this is a key interest of ours, is actually making this bridge as secure as possible. So Brian, what are some of the real life use cases using SafeCoin blockchain so far? Can NFTs be issued on SafeCoin blockchain? So it's so funny, is because people for a long time, people said, are NFTs a real use case? And now they have become, just within 6 months, they've become the #1 example of a use case. So it's really funny. It's interesting how all of this changes very quickly over time. So Brian, we're actually, we have an NFT marketplace in testnet. It's based off Metaplex, and it works with this bridge. And we're expecting to have that out within the next, I don't want to freak any of our developers out, very soon, within the next 10 to 14 days. I think I can say that because we are so close that that's not an unrealistic timeline. So that works now in testnet. It's being developed every day by multiple developers, and they're all volunteering. They're just incredible people, and so it will be moving into production very, very shortly here. And so we're excited with that. We're talking with, I spent last night talking with a few different artists and NFT marketplace people who are interested. So it is very, very exciting to have things like that coming. Now SafeCoin also, I won't show you here, but yeah, so we're actually starting to bridge other projects over. So there's some projects who are in the Solana ecosystem who are having congestion issues right now, for instance. And so we've been talking with them and setting up ways for them to bridge over so that they can work, so that they can run their dApps and other infrastructure with us. And at the same time, they get to decentralize a lot more. So it's not that we're trying to steal from Solana. It gives people more options, allows them to decentralize. It's a great thing. So, I mean, we've got lots of other use cases. People have bought stuff with SafeCoin. We've had stores. We do many things with it. But yeah, you pointed to NFTs right away, and it's very interesting. So yes, we are aware. We're aware of the interest in NFTs, and our market's almost ready to go. So we're excited for that. Okay. So if I jump back to the slide here. Okay, you guys can see the slide okay?
Yeah, looks good.
Great. Okay, so that's probably a good time to go over our roadmap a little bit. So our roadmap is a living document. It does change. Things do get pushed out. Things do get moved forward sometimes. Sometimes stuff comes out sooner. So what are we working on for Q2? We want to do an AVAX bridge and a BSC bridge. So we've just released Safebridge into production. We're calling it Safebridge beta, but it is a production application. So we want to add more bridges to it. We're also looking at getting SafeSwap into production in Q2. So SafeSwap is going to be the first DEX that we put out. We've been working really hard on it. It's getting very close. So we're hoping to have that out in Q2. And of course, SafeSwap will work in tandem with Safebridge, which we just put out. And then of course, Safebridge is the one we've just put out here. Oracle integration, so that's kind of a complex topic. It's actually required for SafeSwap as well, but that's to do with using information through the blockchain, such as prices and other metrics. So we are working on that as part of the SafeSwap release. Actually, the NFT infrastructure, we're calling it NFT infrastructure. This one may be sooner, so we're expecting before Q2 is over, we're going to have a full NFT system put into production. It's not a promise, but we're pretty confident at this point. Token registry, that was actually done. I finished the token registry yesterday. So it's a phase 1 token registry, but it's a registry where actually you can create a SafeCoin token and then have a ticker assigned to it and other metadata assigned to your token, basically saying, this is our ticker, this is who we are, this is our name, so you don't have too much duplication in the system. The registry, Solana's registry, is not super decentralized, and so this is something we're going to be working on, is decentralized ours a little bit more. Some basic lending infrastructure. So again, this ties into SafeSwap release. IPFS and or Arweave integration. So the Arweave integration actually ties into our NFT release. So our NFT release will involve Arweave integration. So that's just stuff that's coming out in the next 6 weeks. Will it all come out? Potentially. We think most of it will. Most of it is very, very close. The things that are not super close right now are AVAX and BSC, but they might just be okay. We might be able to get them out. Next quarter, we have SafeChat 2.0. That's going to be a blockchain integrated SafeChat. So we have video conferencing that we do. We use video conferencing often within our project. SafeChat 2.0 will be a blockchain integrated video conferencing tool. SafeStarter is going to be for funding, people who want to have fund projects, etc. We're going to offer a platform for that. And there's going to be more on that. SafePay 2.0 is a wallet we're working on for all of this, mobile non-custodial wallet. Privacy transactions. So those privacy transactions and privacy smart contracts, some of the privacy transactions are actually going to be coming much sooner, probably Q2 actually. So we're further along on that than we thought we would be. So the privacy components could actually be coming out before Q3. And then lending applications and our integration. By the end of this year, we're going to be doing some more complex bridges, such as a Polkadot bridge and a Cardano bridge. These are harder bridges to do. So they're pushed out further in our roadmap. And the reason they're harder to do is they're not Ethereum based. They're not really compatible with Ethereum, but we do want to bridge with them. Now, another key, well, we touched on all this a little bit, there's improved proof of history algorithm. So improved proof of history, that's where we actually want to take proof of history to the next level. In an ideal world, we could get to a point where we don't need proof of stake. We just wouldn't need it. We could rely entirely on proof of history. We're not there yet, but that's something we'd love to see. Gaming's in there. We want to get into gaming near the end of the year. We want to take our token registry and make it highly decentralized. So that's near the end of the year as well. And then Safe ID, identity management is really, really key for all of the DeFi stuff. So Safe ID is definitely something we want to finish up this year. It could potentially happen sooner though. I don't want, again, we can't promise it. So it's in Q4 for now. Okay. So I think I've come pretty close to hitting my time limit. How am I for time, Sean?
I think you're good. You got a question in the chat there from Brian.
Okay, perfect. Okay, so we have all our contact info on the screen here, and I'll get to Brian's question. So Brian's question is, what do you think of the current debate between cross-chain issues with bridges versus multi-chain? It's hard, right? Because bridges are an attack vector. They just are. Whenever you take, one new technology and then you like merge it with another new technology, you've created like 3 attack vectors, because either one of those new technologies could have an issue, or the bridge connecting them could have an issue. So bridges are a security risk. But I don't think you can avoid them. I don't think bridges can be avoided, because the alternative to a bridge is, like, if you don't have a bridge, essentially you're going to need a centralized exchange. And that's what we've done in the past, is moving from one coin to another. We've had centralized exchanges do it, and we've had sort of custody holders. So your example of that would be, USDT, USDC, where there's a custody holder of fiat, and then that's kind of how they're bridged with fiat. Not a good solution. But it's, for fiat, it might be the only one that we have, but for crypto, we can merge them. So my take on it, Ryan, and it's just my take, is that like when these blow-ups happen, some people are surprised, but I don't think developers are shocked, because you see it, like you see huge potential. This is very new field. All this stuff is new. And, I'm hoping, because we're presenting to UBC, that I expect big leaders of the future will get to see this and will do big things. And, maybe this will help them in some way. Basically, we're just at the beginning. So blockchains had many blow-ups since 2009, and we'll have many more. I think we just need better bridges. We need to be much smarter about how we implement bridges. When you look at the hacks that happened, in hindsight, they look entirely preventable. And so we just have to get better. We have to get much better. It's okay to have a little bit of redundancy in your security. It's okay to have more than one security mechanism. That's okay. It's okay to check more than once. All of these things are okay. And so we have to take it seriously. There has to be more checks in. There has to be more redundancy, more reliability. I don't think bridges are going away. I don't see that at all, but they're going to have to get a lot better than they are. Yeah, you bet. Thanks for the question, Brian.
So, Jeff, we're nearly at the top of the hour here, and that's great. Such a great presentation, and really exciting to see, all of the really important challenges that you guys have on your development roadmap, and how you're thinking big about these things, how you're making decisions about, using proof of history, and which is in itself kind of a brave decision, because it's so new. And, for people, like researchers at blockchain at UBC, these are, really exciting challenges from a research perspective. So I do hope that there will be, students and their supervisors who really be interested in taking up the challenge and working with you. So for me, I did want to ask you, you talked about bridges in particular just now, but you also talked about the multi-threading, you talked about proof of history. And a lot of the time, what I heard was the focus on efficiency. So I guess, I sometimes wonder, in terms of the way that I look at blockchain technology as a technology that really should be focused more on trust. And I guess that gets us into, thinking about these security breaches that can happen. And I'm wondering if, like in your reflections, there's always, you know, in the design of blockchain systems, the trilemma: decentralization, security, scalability. And when I hear efficiency, I often hear, you know, we need to be able to scale. We need, you know, faster throughput. We need, but what do you see as the relationship between these things? And maybe what do you see as, you know, I find that different protocols have different sort of place emphasis on different, you know, of these kind of values, if we call them values. What do you think is kind of most important for you guys? And then how is that reflected in your design, would you say? Just to kind of end on that.
That's a great question. Thank you, Victoria. So I think they're interrelated for sure. And we definitely, I'll admit, we sell it as efficiency, but there is a little bit more to it. Like when you think of consensus, like when you think of what consensus should be, it should be, and this is, yeah, you know, I'm sure there's hopefully some really, really smart people will watch this video, much smarter than me, and they'll do great things in blockchain. And I think consensus should be something that is rule-based. If it's really, really designed well and the science behind it is sound, it can be a rule-based where all the nodes look at the data and say, oh, yeah, well, we agreed to do it this way, so that's what we're doing. And then that's the end of your consensus. And so if you can achieve that, it is both highly secure and highly efficient, because the inefficiency in consensus right now is that we don't have that ability. We're kind of cheating a little bit. We're saying, okay, well, we don't really know, so we're just going to go with whoever's got the most hash power, or we're going to go with whoever's got the most coins, and then that's going to be how we make our decisions. So not that unlike how banks make their decision, really. It's better. It's far better than what a bank does, but it's still very rudimentary. What we do right now is we make these arbitrary decisions, like we'll go with whoever has the most coins will decide for us, or whoever got the most hash power will decide for us. And that is an attack vector. It is highly inefficient. It creates the inefficiencies in the blockchain, which slow the blockchain down. It's trust-based in the wrong way. We're trusting that the person with the most hash power will make the best decision. We're trusting that the people with the most coins will make the best decisions. So it'd be nice if you can just trust the rules. If you have really, really good science, much better science than we have now, way better cryptography, and a set of rules are put in, and we can just trust those rules to work, then I think you're going to get the best of both worlds. You're going to get the efficiency and the security out of that.
Great. So there's so much more we could dig into. We're going to have to leave it at that for today. Because I know that some of us have to run to our next meeting, and you've spent a good amount of time with us, but we hope you will come back and update us on progress. We hope that there will be people within our community who will be interested in supporting the SafeCoin ecosystem. So it's a beginning of conversations, I hope many of which we will have. So thanks again to you, Jeff, for presenting today, and for you, Sean, for making the connection. And we've got the information where we can reach out if interested to learn more about SafeCoin, and we will see you soon. We'll talk again soon. So take care, guys, and very much appreciated for sharing your ideas and thoughts with us today. Okay.
Thanks so much, Victoria. Thanks, everyone.
Thanks. Take care, everyone. Thanks for joining. Bye-bye.